right? So by default, when you create a console application, the console application will create it with the program class. And if you look at the program class, then you will see that one method is created. That is nothing but your main method. This is nothing but your function also. So whenever I am using the term function or whenever I am using the term method, meaning is same. These are just alternative name for each other, right? You can use the word method, you can use the word function, meaning is going to be same, right? Whenever you create a console application, by default one program.cs class file will be created. You can see in the right hand side one program.cs class file is created, right? And this program.cs class file, this is our class file and this is our class, and this class program class having one method, that is main method. This is a method, and this is the starting point of any or every .NET application, right? So whenever you are creating any kind of a desktop application, the program execution is going to start from the main method, right? So from here only our program execution is going to start. Going forward, we will discuss that what are the different overloaded version of main method, how we can make the main method as static. That will be a separate topic altogether. But for now, you just remember, whenever you start your program and whenever you run your program, the program execution is going to start from the main method, and it's a method. So without method, you cannot write a single line of code. You can write, but you cannot do anything. And one more thing, if you want to write some logic, the logic should be written as part of a method. You cannot write, see, this is a class level. I cannot write integer x. Here I can write integer x and integer y, but I cannot perform some mathematical operations. Like suppose you want to add the two number and store the result in some kind of variable. So you cannot write the logic at the class level, right? See, you are getting some compilation error. So what it means? It means if you want to write some logic, if you want to perform some kind of operations, that operation might be getting some data from the API or doing some database operation to store the data, or you are performing a complex calculation operation to calculate the GST, to calculate the profit, to calculate the sale, or if you are trying to place one order, right? If you want to do, if you want to call some payment gateway APIs, right? And or even if you want to log the error message in the log file. So any kind of operation without function, it is not possible. So without function, what possible? We can only declare the data member, but using this member, we cannot perform any kind of operations. If you want to perform the operations, then what you need? You need to declare a function. As part of a function, you can also declare variable. And if you don't declare, you can also declare here also. That is fine. You can access them like this. But if you want to perform some kind of operation, see, this is arithmetic operation, right? And this is assignment operation. If you want to use any kind of operators or logical arithmetic or any kind of a conditional statement, if else, any kind of a looping, function is mandatory. Without function, you cannot write. It is not possible to write if else statement here, right? If true, I cannot write like this here, right? You cannot write like this here. So if you want to write any type of a conditional statement, it should be written within a function or within a method. Is that clear? Hello?
Yes.
So without function, you cannot do anything. If you want to write any logic, if you want to perform any kind of operation, function is required. Okay, now let us see the definition, what it says. A function is a group of related instructions, or you can say a function is a self-contained statement, and when it is called, it will perform a specific task. That means whenever you want to group set of related instructions or related statement, then you can group them inside a function, and when you call that function is going to perform a specific task, right? That task might be a small task or a big task, that doesn't matter, but when you call the function, that task is going to be performed completely. And second thing, function takes some input as a parameter. So you can say input parameter. And it is also possible that after performing the operation inside the function, it is possible that the function might return some value. So two things you need to understand. So function taking some input parameter and returning some result. So here input parameter and returning result. We'll discuss these two things in detail, right? So if you, and the most benefit or the biggest advantages of function is code reusability. Code reusability means what? Now, once you create a function, then you can reuse the same function multiple times inside the program. So if you create a function called addition of two numbers, then you can call that add function anywhere you want in your application. That means you do not need to write the logic again and again. What you need to do, you just need to call the function where you need those logic, right? That means code reusability is the biggest advantages of using function, right? So now let us see the different kind of functions. There are basically two types of function. One is built-in function, or you can say predefined function, or you can say library function, and other category is user-defined function. So predefined or built-in or library function are those functions which is already developed by Microsoft, which is already provided to us as part of the base class library, which is already ready to be used by the programmer. As a developer, as a programmer, we only need to use them. Use them in the sense we just need to call them in from our code, right? That means the function which is already defined, the function which is predefined by the framework, or the function which is provided by the framework to us to be used, those kind of functions are called as your built-in function or a predefined function. On the other hand, as a user, as a developer, as a programmer, if we define or if we create the function in our application, then those functions are going to be said as user-defined function. Is that clear?
Yes.
Yes, sir.
My screen is stopped, or everyone can see it? My screen
can
is,
see it.
sorry?
Visible.
Sir, visual, sir.
No, visible in the sense it is scrollable right now.
Yeah,
Yes, sir.
scrollable.
Yes, sir.
Then I think Satyajit, you need to check your internet connection, or you can restart, because everyone able to see and they can identify my screen is working fine. It might be possible that you are having some internet issues, or just restart your network, or restart, just log out and log in again. Okay. So now let us first study the advantages of a built-in function, and we will see some example of a built-in function. Then we will see what is the problem of a built-in function. Then we will see how the problem is solved by using the user-defined function, right? So advantages. So one of the most important reason you should use library function or built-in function is simply because they work. Simply because the work means, suppose they are provided one function for any specific purpose, it means that 100% that function is going to work. There is no chance that the function is not going to be work. Why? Because if the framework providing you some function,
Sorry about that, sir.
right? So the first reason why should you use library function is because they are going to work 100%. If you are using any predefined function or built-in function, they definitely the 100% going to work. And the reason is because once the developer team of Microsoft to develop one function, then that function is going to be tested in multiple phases, right? So if anybody having any real-time experience, then they might know whenever we develop we develop our code. So once the development phase is completed, then we hand over the code to the QA team, right? Quality assurance team, right? So the QA team is going to perform the testing, whether the function is working as per their requirement or not. After QA team, they will hand over the function or hand over the functionality to UAT team, right? The UAT team is going to test whether the function is working fine or not. After the UAT team, they will provide that code or functionality to the client for whom they are developing the application. The client will check whether it is fine or not. Once the client gives you the approval, then we need to deploy such code or such functionality into your production server, And that means there are at least a 2 to 4 layer before your development to the actual production, right? And the same thing is also happening in this case. Once one function is developed by the Microsoft team, this development function is going through different testing phases, right? And once it passes all the testing phases, then only they are providing that as part of their class library, and that we are going to use. So we need not to be worried about whether the function is going to work or not, even though the function are also optimized for performance. It is not like that it is just they are created and provided to you. They are also going to perform the performance testing, whether the performance, what benchmark they are setting, whether they are getting or not, that will also test, right? Right. So basically 2 things. First of all, it is ready to be used 100%, it is going to work. Second, they are optimized for performance. If you are going to use any built-in function, then definitely they will going to provide you better performance. That as a developer, we no need to define the function. That means it saves our time. Suppose one, for example, that write line method is provided by Microsoft, right? So suppose I'm writing one console.writeLine, right? So you can say this is a function, this is a function. We do not have to define this function. We just need to write the function. See, if you need to write the logic to write something on the console, then how much time it is going to take? So the logic is already written by the development team as part of this function. So we just need to call the function. This is nothing but your function call. And this write line function is defined somewhere in the base class libraries, which we do not have access. We cannot see the code because we do not have access, or we cannot modify the code because we do not have access to the code part. So what access is given to us? Only the signature. If you want to this method signature is this is taking some input parameter, and this method is going to return you something, right? So this is what method signature is given to you. So it will save our time because the implementation part is already developed by the Microsoft team. We are only going to use the function. That means it saves our time. So these are the advantages of using built-in function. Is that clear?
Yes, sir. Thank you.
Okay, fine. Now let's see some of the examples. Say here, I do not write to implement the logic from finding the square root of a number. So there is a method in the math class. There is a static method, and if I provide the number 25 to this square root method, then it will return me the square root of the number. Okay, let's run the application. See here, how many built-in methods we are using? Can anybody tell me? You can see square root of 25 is 5. So that is fine. So how many built-in methods or predefined methods we have used here?
3.
Map.
Sorry?
3 methods.
In any other answer? 3, what are these?
HQRT, then write line, and this read key.
Yes, these are 3 methods which is provided by framework. Even though main method you can also consider as a built-in method, but its implementation is going to provided by us, right? This is also built-in method, right?
Yeah, sir.
But this method implementation we are going to provide. The signature defined by the Microsoft team, right? So if you want to use the main method, you have to use like this. See, if I write this, it is not going to give me any error. But my program execution now is not going to start from here, because if you want to execute your program execution, the main method, the capital M should be the capital M. In this case, it is not small m. So it is a user-defined method, right? But it is not going to be called from the operating system to start our program execution. See, whenever we want to execute, the execution is going to start from main method. But the main method signature should be like the M should be capital. But in this case, the M is lowercase. Now, if I start run the application, then it is saying me that there are builder. Would you like to continue or run the last successful build? Why I'm going to run the last successful build? I want to run this build now. So click no. and you will see that program does not contain a static main method suitable for entry point. That means this main method is a built-in method, but its implementation is provided to us. So we can modify this method body, right? For this type, these are also predefined method, but the implementation is provided by Microsoft. We cannot modify the body. This is a built-in method, but this method implementation, this method body, we are going to write as per our requirement. Is that clear?
Yes, sir. Thank you.
Okay. So this is the square root function, and you can get just like this. There are many functions are available. If you go to the math class, right? So whenever you want to check what are the methods available in a particular class, simply right click and go to definition like this. See, right click, select go to definition. So once you select go to definition, then you will see that lots of functions are there. Round function, log function, APS, absolute function, right? Max function, mean function, sign function. So many functions are there in this class. Power function, SQRT function, truncate function. So if you want to see so what is the use of this function, just click on this. Return the square root of a specified number. The number, what is D? So D is nothing but the number that you need to pass to this method. The number whose square root is to be found. Return one of the values in the following table. Following table, D parameter return value 0 or positive. So whenever it will return a positive value or 0. The positive square root of D, negative system dot equals not a number. If you are passing not a number, then you will get a negative value, right? So whenever you want to see what is the use of that method, just expand that method and just try to read what is the method is all about, what this method is going to do. Is that method taking any parameter? Yes, it is taking parameter. Is this method returning any value? So you can see the return type is double. So that means it is going to return a double value. The number nearest to the value that contains number of fractional digit equals to the digits, right? So you just try to figure out, you just try it. So just call this method math.round and provide two values and see what value it is going to return. And that return value compare with this method signature. That whatever the information they are provided, is it right or wrong? You will see that information is absolutely fine. So for what purpose this method is designed, this method is going to perform that particular functionality. So round function means it will round a number to its nearest digit, right? You cannot use the same thing. You cannot use this function round for other or additional or other responsibility or other type. This round function functionality is defined and that is fixed. You cannot modify or you cannot change, right? So what are the limitations of a predefined function? All the predefined functions are contained limited task only. What it means? It means for what the purpose the function is defined, the same purpose it should be used for. If a function is defined for finding the square root, means this function is only going to be used for finding the square root, right? It cannot be used for finding the average of multiple numbers. So it is going to be fixed. It is going to be do a particular task. For the task for what it is designed, that particular task is going to be performed by the function. So whenever a predefined function is not supporting our requirements, then we need to go for user defined function. See, suppose you want to develop one application where you need to design one application that method. You need to design one method where you will provide two integer numbers and 3 floating point numbers, and you need to add those 4 numbers and you need to return the result to the column, right? This functionality is not provided by Microsoft, right? No predefined function is there to support this one. So in that case, if the predefined function is not fulfilling our business requirement, right, then as a developer, as a programmer, we need to implement our own business related information or business related functions, and those functions are going to be called as user defined functions, right? So the simple thing, if the predefined function is not fulfilling our business requirement, then we need to go for user defined function. Is that clear? Clear or any question?
Yes, sir.
Okay.
Yes, sir. Thank you.
Okay, now let's see what are user defined functions in C#. So simply think, as a developer or as a user or as a programmer, if we defined our function as per our business requirement, then such functions are said to be user defined function. See, most of the predefined functions are very limited tasks. They are going to perform simple tasks. But if you want to perform a complex task, right? If you want to perform some database kind of operations, if you want to perform some payment gateway kind of operations, or if you want to call an additional API to get some data, right? If you want to perform, if you want to place an order kind of operations, right? So basically, if you want to perform some complex operations, right, then you need to use, just give me 1 minute. Okay. So whenever you want to perform a big operation or complex operation, right? And if you want to optimize the code, then you need to use user-defined function, right? So let's read the definition. The user-defined function are the function that are created by the programmer, a user, or a developer, so that he can use it many times. Already we discussed, if we create a function, then that function may be going to be used at multiple places. That means once you create a function, you can use that function any number of times. So it might be 0 times or it might be n times. If you are calling the function from 5 places, then it is going to be used 5 times. If you are not calling the function from anywhere, then it is going to be used for 0 times. It reduces the complexity of a program, optimizes the code. So basically functions means what? Now if you can write all the functionality inside a single function, but that doesn't make sense. What you need to do, you need to split a big program or big function into many number of smaller functions, so that you can reduce the complexity of the big function or big program. C# allows you to define function according to your needs. So as per your business requirement, you can create your own defined function, right? The function whose body is implemented by the developer or user is called user-defined function. In this case, not only we are defining, declaring the function signature. So what is function signature? We'll come to that part. Not only we are defining the function signature, but also we are providing the function implementation. Implementation in the sense function body. So we are going to provide the body to the user-defined function. Second definition, as for client or project requirement. So this is the generic definition, and this is from an experience point of view. If you are having if you are working as a developer or you are working on any kind of a project, then this definition is for you. As for client or project requirement, the functions which we are developing are called user-defined function. Always user-defined function are client-specific functions or project-specific function. As a programmer, we are having full control over user-defined function. See, in this case, we do not have control over this sqrt function or the write-line function because these are predefined functions. The function body is provided by the function body is provided by the developer team of Microsoft. So we cannot change or we cannot have control over the body. But if we create a user-defined function, for example, let's say void is some method, right? So we have full control over the user-defined function body, right? So whatever we want, we can write as part of the body. If we want, once we create the function, then if we need, we can modify the body, right? If we want, even we can also delete the function. There is no problem. So what it means, we have full control over the user-defined function. So whatever we want, we can do. We can create a function, we can update a function, we can modify a function, even we can delete a function. That is completely, it is under our control, right? So as a programmer, it is possible to alter or modify the behavior of any user-defined function, that is we just see. And if it is required, the coding part is because the coding part is available. So whenever we create a user-defined function, then the coding part is available to us. So we can do anything we want. So see, this is I'm creating one method. So this is today I created this method. Tomorrow I can modify the function. Na? So instead of this, I just modify this. So because the source code is available to me, if the source code is available to you, then whatever the thing you want, you can do this, right? Tomorrow, going further, we'll discuss some additional thing. For example, suppose you will say that, sir, this is a class, and this class is provided by Microsoft, or you can say it is a part of our base class library. But I want one class, but I want one function, and I want to invoke that function using the math class. Is this possible? Yes, it is possible. Then you will say, then you will tell me that, sir, we do not have access to this class. Then how we can add a method to this class? We are not going to add a method to this class. Then how we can call the method using the math class? This is possible. There is a concept called extension methods. Extension functionality. What is the use that extension method? Now we can extend the functionality of this math class. We are not going to modify the code of the existing code. Rather, we will create a new class. We'll add one method, and we will add the method in such a manner that we can call that method using this math class. That is also possible. Going further, we will discuss those concepts, but not now. Right? So you can change, modify, update, alter, delete. Whatever you want, you can do with the user-defined function because the source code is available to you. Once the source code is available to you, then you have fully control. You have full control over the code. Is that clear? Clear or any question?
Yes, clear.
Okay. Now the important part. Now actually we are moving into the main concept. How to write a user-defined function in C#. So first of all, look at the signature. So many on many internet or many website or internet, you will see that access modifier and specifier, they are saying both are same, but believe me, both are different. So this is the signature of defining a method. Some of the part is mandatory, some of the part is optional. So this is access specifier, this is modifier, this is return type, this is function name, this is parameter list, and this is function body, right? So let's see how to write a function. So first of all, the function should have a name. Without name, you cannot define a function, right? That function name is nothing but you can say it is an identifier by using which you can identify this function. And the function name is mandatory. Without name, you cannot create a function. Second is, you can see this is the parameter list. Parameter list means if you want to pass some data to this function, then you need to define. If your function takes some data, if you want some input data to this function while calling, while someone calls this function, then you need to define the parameter list. So you can define any number of parameters and of any type. It doesn't matter whether the parameter type is a built-in type like integer, float, character, or any predefined like string, object, employee, student, etc. Right? So you can define the parameter list, and it is optional. It is possible that you can define the function without parameter, that is 0 parameter, or n number of a parameter. So this parameter list is optional. A function should have access specifier, and this is a function should have access. It's okay, Pratik. No issue. Okay, see, then the function should have a return. Okay, optional. Then the function should have a return type, which is mandatory. See, so after function name, which is mandatory, function parameter list, which is optional, we have something called a return type, right? Return type is mandatory. So after performing, after executing the task, does your method going to return any data? Yes, it is going to return data. Which kind of data this method is going to return? Integer data. So the return type is going to be int. After executing the function body, the function is going to return an employee object. That is a reference type. So if your function is going to return an employee object, then what is the return type? Employee is the return type. After executing, and so sometimes it is also possible that after executing your function, it doesn't return any data. So if your function doesn't return any data, then what should be the return type? Void is the return type. So the return type is going to be mandatory. A function should have access specifier, which is optional. It is not mandatory, it is optional. So whenever you create a function, if you have not specified the access specifier, by default it is going to be private. So this access specifier is optional, and if you are not using, then by default it is going to be private. That we will discuss in detail. Access specifier is a very important concept. We'll discuss that concept in detail. So access specifier means it is optional, and what are access specifier? Private, public, protected, internal, protected, internal. These are nothing but your access specifier. And what is this modifier? Modifier is optional, and whenever you are creating the method, how you can access the method, who can access, how, whether this method is going to be inherited to the child class or not, how you can define the method. So all these things are going to be defined by the modifier, right? So we'll discuss these things in detail now. So as we have 5 parts. We have 6 parts. 1, 2, 3, 4, 5, and function body. So whatever the business logic you want, you can write as part of your function body. So 6 parts. Let us discuss this 6 parts a little bit more. So function name, it is mandatory, as we discussed. It defines the name of the method or function. I already discussed. I'm going to use the term method and then function interchangeability, and the meaning is going to be same. If I'm saying method, if I'm saying function, then both are going to be same, right? The method signature consists of method name and parameter list. So whenever I'm saying method signature, you need to consider 2 things. What is the name of the method, and and how many number of parameters this method is taking. So method signature means these 2 things. The methods are identified by their name. So if you want to identify this method, then you will identify this method by its name. The rules for giving function name as the same rules for giving a variable name. So the rules what we discussed in our variable class to provide the name, the same name is going to be, same rule is going to be applied here. You cannot create a function with a digit. The function can contain alphanumeric character. The function can contain a special character called underscore. Apart from these things, nothing is going to be applied. So the same rule is also followed here. So this is all about function. Now, parameter list. It is optional. It defines the list of a parameter this method can accept. A function can take 0 parameter. If the method doesn't take any input from the user, then it doesn't need to define any parameter, or more parameter, or you can say n parameter if it has to take any parameter. Right? So it may or may not take any, it may or may not take any input. Right? So it may or may not take any input. If it is taking input, you need to define the parameter. If it is not taking input, you do not need to define the parameter. Is that clear?
Yeah. Yes, thank you.
Yeah. So after these 2 things, the third thing that you need to define is return type, and it is mandatory. It defines the return type value of the method. A function may or may not return a value. It can return, but if it can return maximum 1 value. It cannot return multiple values, but it can take multiple values as parameter. See, whenever you are performing any operation, after executing the function, you might be return some data, or you might not be return some data, right? So if you are returning some data, maximum 1 value you can return, but you can take any number of input parameter. But if you are returning some value, you can return maximum of a single value from this method. And if you are not returning any value, then you need to mention the return type as void. If you are returning integer value, you need to mention the return type as int. If you are returning a string value, you need to mention the return type as string, right? Is that clear? And if you are returning any complex type like student, employee, product, then you need to mention the return type as student, employee, or product. Is that clear?
Yes.
Okay. The next thing is access specifier and modifier. Let's see what are the use of these two things. So access specifier, it is optional and it defines the scope of the method. So what it means now, this access specifier will define from where you can access this method. That means it defines the accessibility of the method, such as the private, protected, public. If you define the method access specifier, accessibility as a private, then from where you will access this. If you define this as a public, then who can access this method? If you define this as a protected, then who can access this method? Private, protected, internal. So there are other accessibility modifier also there. We'll discuss those things in detail when we discuss access specifier in our upcoming session. So for now, so access specifier is basically going to provide you or going to decide who can access this method, right? And the next one is modifier. It is optional and it defines the type of access to the method. Type of access. It is provide the scope who can access, and it defines the type of access to the method. For example, static, virtual, partial, sealed. So modifier means static, virtual, partial, sealed. Access specifier means private, protected, public. So you need to remember these things. These are your access specifier. These are your modifier, right? Both are having these are having different meaning, and these are having different meaning, right? So you need to be understand this thing. If you declare the method with static modifier, then you can access the method directly without creating the instance. If you declare the method with the sealed modifier, then this method is not going to be overridden under a child class. And if you declare the method with partial modifier, then you can split the method definition into two parts. And these are going to be separate topics. We'll discuss what is sealed class and sealed method in our OOPS concept. We'll discuss what is method overriding in our polymorphism concept. We'll discuss what is partial classes and partial method in our OOPS concept. Now, okay. Now, if you go to the CSR course overview, you will see that so there is a specific concept called access specifier. Here I will discuss you private, protected, public, all the access specifier in detail. So there is a static concept is here, static. So you can say static. What is the use of static keyword? Then you have something called method overriding, right? Method overriding concept is there. Partial classes and partial method is there. Sealed classes, sealed keyword is there. Partial keyword is there. Static keyword is there. So each thing also, whatever the access specifier and modifier I'm showing right now, we will discuss each and everything in detail in our coming session. So no worry if you are getting confused how we can access a method without creating an instance. We'll discuss this thing in detail. What is the importance of a sealed keyword? We'll discuss. Partial, we'll discuss. Everything we'll discuss in detail. But for now, you have to remember access modifier and access specifier are two different things. Both are not same. And in website or many article or many YouTube videos, you will find that they are saying access modifier and access specifier are same. But those are two different things. Okay, now function body means it is the actual place where you will write your business logic. So if you want to, and this open and close curly braces, as part of this open and close curly braces, whatever statement you are going to write, this is nothing but your function body. Right? Access specifier and modifiers are not same. Method and function both are same. So we can use the term method and function interchangeability. Right? Now let's see how to create a function. We have discussed the signature. This is the method signature. What are the things? We have access specifier, modifier, return type, function name, parameter list, and a function body. Who is are mandatory? Return type, function name is mandatory, right? Access specifier, modifier, parameter list are optional, and the body is going to be mandatory. Because if you are not providing body, then what is the use of this method? So body is important. See, so in this example, so you can see we are using some of the things. So what is the name of the method? Max is the name of the method. How many parameters this method is taking? 2 parameters this method is taking. So in parameter list, we have 2 parameters. In method name, we have defined the method name as max. What is the return type of this method? integer is the return type of this method. What it means? It means this method is going to return the integer type of data. And what is this public? Public is nothing but your access specifier. And in this example, did we use any modifier? No, we have not used any modifier. So what we used? We used access specifier, that is public. We used return type, that is int. We use function name or method name, that is max. We use parameter list, that is int x and y, and this open and curly braces. Within this open and curly braces, whatever statement we return, that is nothing but your function body. Is that clear?
Yes.
Okay. Now, what is function signature? See, we need to understand this function signature concept, because going further, when we are going to develop polymorphism, right, where we will define the same function multiple times to achieve multiple behavior, at that time we are going to use this term function signature. So we should know what is the meaning by a function signature. So you can see here I have written this statement: public int subtract numbers integer m and n. So in this case, don't think that a public int as part of the function signature. Public int as are not part of the function signature. Then what function signature meaning is? Function signature only contain the name of the function and the parameter. The function signature consists of two things. What are the things? First thing is method name, what is the name of the method, and what is the parameter list. So these two things are the part of function signature. So then you will see that, sir, is return type is part of the function signature? No, return type is not considered as part of the function signature. Later I will discuss, when we will discuss method overloading, at that time I will discuss why return type is not considered as part of a method signature. But for now, just remember, if someone asks you what is method signature, you just need to tell method signature is consist of two things. One is the method name, and the second one is the number of parameters this method takes. So these two things combined together, we will say this is the signature of the method. And these two things are required to call the method. Is that clear?
Yes.
Okay. Okay, now. And here I have written the code wrong, so let me modify this one. Okay. Subtract number integer num1 integer num2 integer result equals to num1 minus num2. Okay, and result is error. We can take this code, we can copy this one. Okay. So now we have discussed what is method signature, and we have discussed what are the things required to create a function, right? Now, once you create the function, the next important thing is how to call the function, right? So you define the function somewhere else, and you need to call that function from some other part of your program. Then it is also important to understand how to call the function, right? So let's see. When a method is invoked, a request is made to perform some action, such as setting a value, printing statement, performing some calculation or complex operation, doing some database operation, returning some data, right? So as part of the function, whatever the functionality you have defined, when you call that function, then those things are going to be executed. What are the things you can do? You can set a value, you can write some printing statement, You can perform some complex operation. You can even do some database operation. Even you can make some API call, right? You can get the data from an additional API. And even though after performing all these things, it might be possible that you may return some data from your function, right? Then to call the method, what we require name of the method and any data this method is expecting, right? For example, if I want to call this method, then what I need to know? I need to know the name of the method. I also need to know what are the parameters this method is taking. So once I know this method name and the number of parameters this method is taking, then I can call this method.
Your voice is not heard.
Yeah, actually I was on mute, right? So in order to call this method, so what are the things is required? First of all, you should know the name of the method. Second, you should know what are the input parameter it is taking, if any. It is possible that the method doesn't take any parameter, but if it is taking, then you should know what are the data I need to pass while calling this method, right? So when we invoke a method, the control gets transferred to the called method. So there are two things. One is called method, another is calling method. For example, so in this case, so see, so in this case, you need to remember two things. So what is called method and what is calling method? So here, who is calling this subtract method? Main. So here main is the calling method. Which method is called? Subtract number. So subtract number is the called method, right? So that you need to remember. So main method is the calling method. Subtract number is the called method, right? So we need to understand this point when we invoke a method. So here you can see we are invoking this method, and to invoke a method, what are the things we need to know? We need to know the name of the method, and we need to know the number of parameter this method is taking. In this case, we know the method name is subtract number, and this method is taking two parameters. So integer number 1 and integer number. So I need to pass two integer number to this method while calling. So I'm passing these two number. This main method is my calling method, and this subtract method is my subtract number is the called method. Now, so when we invoke a method, the control gets transferred to the called method. Then the called method returns the control to the caller method. So when this method is invoked from this line number 10, the control will come to line number 14. Is that clear? So when I call this method subtract number, the control will come from line number 10 to line number 14. Let's see practically. Right? So see function F10. So from line number 10, see my controller. So you can see this is nothing but your controller, this ROL. So this is nothing but your controller. And when I execute the line number 10, the control from the caller method, the control will move to the called method. See function F10. So I have not put any debug point, so you cannot see. Let's put a debug point here also, and let's try to run the application once more. Function F10, from here it is coming to line number 15 or not. So from this caller method, the controller come to this called method, and once that is what I have written. When we invoke a method, the control gets transferred to the called method, right? Called method from the caller method, right? From the caller method, the control gets transferred to the called method. Then the called method returns the control to the call method. Then the method, then the called method returns the control to the caller method from where we call the method in the following three conditions. Then once this method completes its execution, again the controller will come to the caller method. Caller method in this case, which one? Main method. So from once it executes the line number 17, it will come to the caller method. To where? Now from where this method is being called. So it is called in line number 10. So it will come to line number 10 and execute the next step. See? So this statement executed, this statement executed. Then it is coming to which statement? From where this method is being called. So in this statement, this method called na, again it will coming back to this method, and from here again it will continue the execution. Is that clear? Is that clear? How this caller and caller functionality work?
Yes.
Okay. And one more thing I need to tell you. Suppose you want to debug one method and for which you do not have any debug point. So in this case, suppose I want to debug this method, but I have not provided the debugger point. Is that possible? Yes, it is possible. Let's see how. See, when you move to the next line, so from this line, generally, if you we have two options. One is function F10 key and one is function F11 key. If you press function F10 key, it will come to the next line. Next line in this sense, which line? Line number 11. But if you press function F11 key, it will go inside the function, right? So now we are in the subtract number function. Subtract number. If I press 11, the controller will move inside this function. So now I'm pressing F11, function F11. See, the controller will move to this point or not. So you need to know how to. So in real-time application, while you are debugging, it is not possible to put the debug in a. In this case, it's a single class having two methods. In the real time, you might be have 100 classes. You might be have 1,000 methods, and you can debug the required function. So indeed, in that case, it is very difficult to identify the classes and identify the methods and put a debugger point. So what is the best solution? Just you need to use, if you want to debug one method, and once the control come to that particular method, just press F11, it will take you to the method definition of that method, and you can debug that method. And once it is debug that method, again it will come back to the place from where it is being called the method. Is that clear? Yes or no?
Yeah.
Okay, fine. Now, so here we need to understand. So here you need to remember one thing. The called method returns to the caller method in the following three conditions. When the return statement is executed, when it
it is necessary to call the function only in main method only.
No, it is not necessary. In this case, I am just showing the use of a function. You can call, suppose I am creating another method. So this is add number, right? So this is add number method. So from here also I can call the add number method. It is not necessary. I can call the add number method from here also. It is not necessary to call the method from the main method only. You can call the method from another method, from anywhere. So this is the reason now we can define one method and we can use it from multiple places. So from whichever place you want to call the method, you can call it. It is not necessary to call the method from the main method only. In this case, you can see we are calling the subtract number function from main method, and we are calling add number function from the subtract number method. And now this add number function is the called method, and this subtract number is the caller method for this add number method. So you can call from anywhere. It is not necessary to call the method from the main method only. You can call it from anywhere. So going forward, whenever we discuss the OOPS concept, then the actual and the real use of a function comes to picture. But for now, I'm just discussing the basic concept. Basic concept means what are these? What are functions? How to use function in a class? How to define a function in a class? Those things we will discuss once we start discussing the OOPS concept. But for now, how to create a function, how to call a function, what is the signature of a function, what are the things we can define inside a function? these things we are going to discuss now. Is that clear?
Yes, sir.
Okay. Now, so when a function return to its caller method, so see, in this case, I'm calling this method. When this method return to its caller method, right? So best approach when we have to use static and non-static method. So this is a very interesting topic, and see, I will show you the real-time use cases of static and a non-static method and the static and a non-static member. So if you go to my course syllabus, static and non-static are very important. So we need to understand those things in detail. So don't worry about this concept. So you can see static and non-static members. So static, I will show you what is the real-time use of static. Static means it is not only static method and static method. Even you have static class concept is there, static constructor concept is there, static data member concept is there, static member function is there, right? So what is the real-time use of static, and when to use static and when to use non-static? What is the difference between static and non-static? Everything we are going to discuss as part of this course. So don't worry, and just look. That's why I put the things in the course syllabus so that you should not be any confused. If I am not discussing at the same time, but after some time I'm going to discuss. That's why I'm putting the things in the syllabus in a detailed manner, right? So I'm not going to skip anything. It is as part of our course syllabus, and when I discuss the static and non-static, and I will give you 100% guarantee that you will understand the concept, when to use static, how to use static, and when to use non-static and how to use non-static. Is that clear? Okay. See, when the return statement is executed, it will return to the call function. It will return to the caller function. When it reaches the method ending closing curly brace, when it throws an exception which is not handled in the call method. In this case, when it reaches to the closing curly braces, it is returning to the called method. But even you can return to the called method by using return keyword. Right? So in this case, this statement is not going to be executed. From here only, it will return to this called method. Let's see. See, after return, this statement is not executed. So it is returning to this function, right? So you will see that the output statement is not there, right? So this is one approach. When the return statement is executed, it will return to the caller method. Second is when it reaches the last line of code in the function. So in this case, what is the last line? So this is the end line, right? So once it executes this line, automatically it will return to the caller method. Let's see. So in this case, see, it execute the last line, it will return. So you will see that last line will be printed in the console, right? And when you throw any exception, right? Suppose I'm doing one thing, suppose some exception is thrown which is not handled in your code. See? Suppose I am implementing try class block here, and I am writing the statement here, right? Okay. Function F10, control comes to this place, right? And once it executing, acha, I have done the number division by 2. See, from this line, the control come to the calling method, and as it is an exception, it is executed in the catch block, right? So in the three scenarios, your method control return to the caller method. So what are the scenarios? when the return statement is executed. So if you have return statement written, then when that statement is executed, it will return to your color method. When it reaches the end of the when it executes the last line, then by default it is going to return. And whenever some exception occur, and if that exception is not handled in your code, then also it will return to the color method. Is that clear? And what are the different scenarios when the method return from called method to the color method? Yes or no? Any question related to this?
Exception handler is not showing any. I
Exception,
would like to know that exception
No.
handler.
exception handling is there in our syllabus. So
Yeah.
I'm just showing you. This is a completely new chapter. Exception handling I'm going to discuss in detail. Right? This is there in the syllabus. What I'm showing you now, there is something called exception handling, and whenever some exception occur, so I'm showing you now the exception handling example. So this is the exception handling. So whenever this statement is executed, so it will throw some error, and that error is coming to the color method. It is not executing the next line. So what is exception handling? How I'm implementing this try catch, all these things we'll discuss later, not now. See, so this statement is the line number 24 is executed, and once I press F10, it will not execute line number 16, rather it will come back to the main method. See, it is coming back to the main method or not? So this is exception handling. And whenever some runtime exception occur, and if you have not handled that exception, then automatically the control will come back to the method from where this method is called. So this is color method, and from where this subtract member method is called, it will come back to that method only. Right? Is that clear? So going further, I will discuss what is try, what is catch, why it is not control comes to this particular location, and why it is come to this exception catch block. I will discuss this thing in detail. But for now, what you need to remember, from the called method, in 3 different scenarios, the control will come back to the color method. One of the scenario, when it reaches the last line of the code, or you can say close curly braces, and when you have written the return keyword in your code. So what is return statement, we will discuss after some time. And whenever there is some unhandled exception occurred in your application code inside a function, then from that function it will come back to the color function. So these are 3 different scenarios when your method, when the control from one method is come back to the color method, right? So these are the 3 different scenarios. Now let us see some of the examples to understand. Okay. So in this case, you can see I'm not using any method. I'm simply using the main method, and here I'm just doing the arithmetic add operation. I'm just doing the number 2 division. I'm initializing x and y with value 10 and 15 respectively, and then I'm adding this x and y value and storing the result in some variable, and then I'm printing the result. See, so the sum is 25. That is fine. So you can see. Okay, let me close this one now. Now what we need to do, we need to create a program for this add operation. So how we can do this? So we just need to create a add method, which is taking 2 parameters a and b, and then I'm adding the 2 values a plus b, storing the result in the sum variable. And here you can see the return type of this method is int. So I can return an integer variable from this method, and I'm here writing return sum. This is sum, it is not an integer variable which is holding int value, integer value, and that integer value I'm returning from this method. And when I'm calling this method add, so I need to pass 2 integer numbers. So I'm passing x and y. When I'm passing x and y, so it is actually passing a copy of the x and y. So what x is holding? X is holding 10. So instead of x, at runtime 10 will be passed, and that 10 will be stored in the variable a. And what happened in the case of y? Now y is holding a value 15. So at runtime, so this 15, this y will be replaced by 15, and that 15 will be go and sit in the variable b, right? So at runtime, this a and b will hold the value 10 and 15. So it will do a addition operation 10 plus 15. The result will become 25. 25 will stored in the sum variable, and return sum means we are returning 25 from this add method. And as it is returning any integer value, so whatever this add method returning, I'm storing that return value in the sum variable, right? And then I'm printing the result. Is that clear?
Yes.
Okay.
Yes.
Okay, now let's write the code. Okay, so in this case, let's debug the application. See, so function f10, 10, 15, y. So from here, I'm coming to this place. So now you can see a value is 10, b value is 15, because the x value at runtime replaced with 10, y is replaced with 15. That 10 and 15 are coming as input parameter to this method. Then it is doing the arithmetic operation in sum. It will store 15, right? And it is returning that 15. So why I'm returning sum? Because sum is an integer type variable, and the return type of this method is int. So as return type is int, you can return integer. So when I return, so it will come to this place, right? So this is from this place, the method is called. So it is coming back to this place, and whatever value this method currently see, the sum is 0. That means the assignment is not yet done. So once I press F10, so whatever value this method returning, that will be stored in the sum variable. Press F10. Now please observe what is storing in the sum variable, 25. So this method return 25, and that 25 is stored in the sum variable. Is that clear?
Yes.
Okay. Now please observe one. So here the return type is int. I can write a direct constant value like this. It is also acceptable because 10 is an integer variable, right? But if I write 10.5, what happens? It is going to give you an error. Can anybody tell me why I'm getting this error?
It's a float value. No?
Yes, it's a float value, and you are writing integer. So
Correct.
the size of float is bigger than integer. That's why I'm getting this error. Now I'm writing float, right? So as soon as I write float, here I'm getting the error. Can anybody tell me?
Yes,
The result cannot be
sum of two integers.
Exactly. So this method is going to return a float value, and we cannot store float value directly in integer variable because automatic typecasting is not possible in this case, because we cannot store a higher range data type value to a lower range data type value. So is there any other solution? We can remove this error and we can store that result in the integer variable.
You can declare int as float.
No, I want to store in the integer variable. I don't want to change this. I don't want to change this method signature. This method is going to return float, and I want to store the return data in the integer variable. Is there any
What?
way?
Conversion.
Convert, sir.
So we have many different conversions.
Conversion to
Cast it to integer type. It is going to be acceptable. Other options are there. Can anybody tell me? Convert dot to int 32 is also there. It is also acceptable or not?
Yeah.
But
it is.
what happened in this case? In this case, we were going to lose the data. It will store 10 and we will lose this 0.5. Is that clear?
Yeah.
Yes.
It will round it up to nearest integer.
Yes. So now, if I declare float and if I return an integer value, is it going to work? See here, the return type is float, but I am returning an integer value, but it is not giving me any error. Can anybody tell me why?
The size of float is equal to integer.
See, there is a concept called automatic typecasting, you know. Implicit typecasting. In our typecasting, we have discussed. If I am storing, see, this concept is something like this. You are storing one integer variable, integer I equals to 10. You are creating one floating variable, floating f, and can I assign the I value to the float variable? Is it acceptable? It is accepting or not?
Yeah, it is acceptable. Yeah.
Why? Because the I data type size
I is smaller.
smaller than float. So here you are passing integer. Integer can easily sit in the float type data type. Na? The size of float is bigger than integer. That's why it is acceptable. But if I make this as integer and if I make this as float, then only I am facing the problem. Na?
Correct.
Right? Because you can store integer inside a float data type, but you cannot store float inside a integer data type because there is a chance of a data loss. You cannot store some higher range data type value inside a lower range data type value, but you can store a lower range data type value inside a higher range data type value. Is that clear? Clear or any doubt? Shall I explain once more?
Yes.
Okay. Now whenever you are working with any application, you might be heard something called formal parameters and actual parameters. So that we need to discuss. See, the function definition taking the parameters are called formal parameters, and what parameters you are passing while calling the function are called actual parameters. In this case, this is our function. This is our function. This function we are declaring two parameters a and b. These are formal parameters. While calling the add function, I am passing x and y. So this x and y are nothing but your actual parameters. So these are two terms used in industry. Sometimes you will say, what are the formal parameters this method is taking? Then you should know the term what do you mean by formal parameters. And what are the actual parameter you are passing? Actual parameter you are passing means whenever you are calling the method, what is the argument? What is the value you are passing to those formal parameters are nothing but your actual parameters. Is that clear?
Yeah.
Okay.
But then, what are arguments?
Argument means these actual parameters you can also call as arguments. So if you are passing x and y, this x and y you can treat it as actual parameter as well as you can treat them as arguments. There is no difference between actual parameters and arguments, but these are formal parameters, or you can say these are local variables for add method. So these are your formal parameters and this will be your local variables, right? And these are your actual parameters, or you can say arguments. Okay. So don't be confused with the word actual parameters and arguments. Argument and actual parameters are just alias. You can use the term arguments or you can use the term actual parameter. There is no difference between them. And here these are formal parameters, or you can say local variables. Now we need to understand how this program resides in the computer memory. See, whenever you are running the application, the machine code is going to be stored inside the main memory, right? See, if I started executing this, okay, so there is some error. Okay, let's fix the error. Let's return this sum from this method. Okay. Right. So let's start the application. The application is started. Now come to the task manager. See, you can see, so this is one exe. This exe is loaded inside the main memory, right? So what it means, now whenever you are running one application, the machine code is loaded inside the main memory, something called as a code section. In main memory, something called as a code section. Inside that code section, your machine code of your application is going to be loaded. Is that clear? Once the machine code is loaded and once the application is start executing, so it started executing the main method, right? So what will happen now inside your main memory? So there are two other kinds of memory available. One is heap memory, another is stack memory. This location, which the empty location, is nothing but your heap memory, and this location is nothing but your stack memory. Okay. So as soon as your program execution start, this main method started. So once the main method started, what will happen? Now one activation record area is created for the main method, main activation record area. So this will be created inside the stack memory, main activation record area. So once the main activation record, when the main activation record area is going to be created, when you start the execution of the main method, right? And then you start executing the application. So once you start executing the application, so integer x, y, and this some variables are created inside the main activation record area. So you can see x, y, and sum. Initially, sum will be created with 0, but later it will be assigned with the value 25, right? So the main activation record area for the x, y, and sum variable will be created here, right? And once the control move to the add method, then another activation record area for the add method will be created inside the stack memory. See, so add activation record area is created inside the stack memory, and whatever number of local variables you have created as part of a add method, those are going to be created inside the add method activation record area. So here we have created 3 variable AB sum. So inside the add method activation record area, so 3 variables are going to be created, AB and sum, and these are going to be created inside the stack memory. This main activation record, add activation record, both are going to be created inside the stack. Is that clear? So here and inside the stack memory, only the local variables are going to be created. If you are creating any kind of member variable, those are not going to be created. That will be a separate story altogether. We'll discuss that in our coming session. But for now, this main method having some local variable. How many local variables are there inside this main method? We have something called x, we have something called y, and we have got something called sum. So in the main method activation record area, 3 local variables are created. So x, y, and sum, and they are storing the value 10, 15, and 25. Right? And when the add method start executing, these are, as I already told you, these are formal parameters. Formal parameters are nothing but your local parameters, right? So these are local parameters to this add method. So AB are local parameter, sum is also local parameter. So AB sum is going to be created here.